Hi students, I want to show you how to work on this compounds worksheet. A lot of this is new to you and I would like to spend some time going over it. The first thing that I want to show you is a copy of the periodic table, which you can get online in a lot of places, like just look at images. And at the top of the periodic table, it has a number. It's usually above each element, either to the sides or in the middle, but it's called the proton number. And it has the number of protons or positive charges. So protons have a positive charge and electrons have a negative charge. You'll also hear of something called a neutron, and they're neutral. So I don't know what to put. They don't have any charge at all. They're just neutral. So hydrogen here has one proton, one positive, and the positive will always be balanced by the negative, just like magnets. So hydrogen has one proton, which means it has one electron. Helium has a 2, so it has protons, so it has 2 electrons. Lithium has 3 protons, so it has how many electrons? 3, right? And beryllium has 4 protons, so 4 electrons. So here on your worksheet, you are going to have the challenge of trying to draw what these look like. So I want to help you do that. In the first energy level of these elements, you only draw, well, the element can only hold 1 or 2 protons in the first energy level. It's so tight and small around the nucleus that it can only hold 2 electrons. So here with hydrogen, you have a 1 proton, which means it has 1 electron. And you can draw a ring around that. And so basically it only has its 1 little electron. So every element will always want to get their outermost electron cloud full. And so it will always look to hydrogen, will always look to get its second electron here so that it feels full. So in the first level, you can fit 2. If we had another ring around here in the second level, you can actually fit 8. That's kind of a lot. But hydrogen only has 1 electron cloud around it, so it can only fit 2, so it's always looking for 1 partner to partner up with, to share. The next element is helium. And helium has 2 protons, 1, and so it has 2 electrons, 1, 2. So helium never really binds with anything. They're called the noble gases because they never need to bind because it's completely full. So it's never looking to bind, whereas hydrogen's always looking to bind with something. So the next biggest element is called lithium. And lithium has 3 electrons. Or yes. So it has 3 protons, so it has 3 electrons. So this is lithium. And in its first cloud, it's going to have 1, 2, but then it's full. So then the next cloud can have up to 8. But lithium only has 3 total, so 1, 2, we'll put its third right there. Now because lithium has 7 empty spaces, because it can hold 8, but it only has 1 there, lithium is really looking to bind all the time with some other element to get these to feel full and feel complete. So lithium and hydrogen, who's incomplete, they are on this side of the periodic table because these are highly reactive. they are really trying to bind with anything they can, and will very easily bind with anything, okay? So that's how that works, okay? So when you come over here to this page, what does that mean for you? Hydrogen, because it only has 2 protons on our periodic table right here, it has the 2 proton, or the 1, I'm so sorry. Okay, since hydrogen only has 1 proton, it only has 1 electron, and so in its highest energy level, it can fit that 1. So the number of electrons in its highest energy level is 1, and the number of incomplete pairs, that means how many extra is it looking for? Well, 2 minus 1 is 1. On this next one, you have carbon. Carbon actually is a 6. So that means 2 went into the first shell. So let's see if we can fit carbon on this page that's getting pretty full. Okay. So 2 in the first ring. And we need 6 total. So 1, 2, 3, 4 more. Let's see if that equals 6. 1, 2, 3, 4, 5, 6. Good. But we could have fit up to 8. So there's in the highest energy level, there are 4. And the number of incomplete pairs, how many is it missing to be full? 8 minus 4 means that it needs 4 more to be full. All right. The next thing that I want to show you is this lower part. On this lower part, it's first asking you, what is this made out of? So water, H2O, is actually made up of, and let me get rid of the marker so it's easier to read, H2, so that means 2 H's. An H is a hydrogen, and an O is oxygen. So it's actually made up of 2 hydrogens, and there's no number next to the O, so we can just assume 1. So 1 oxygen. And then it's asking how many single bonds, how many double bonds. Well, we're going to go back to drawing that out. So when we draw that out, we are going to do this. If I had oxygen, and I had the oxygen, I'm just going to tell you, it has 8. So that 2 in the first one, so we're going to subtract off 2. And so 8 minus 2 is 6. That means in its outermost level, it has 6 electrons. And I'm going to forget the cloud around it and just draw it like this. This is called a Lewis dot diagram or an electron dot diagram, and it's the same thing. You could draw a circle, but we're going to leave the circle off so it matches your paper. So I've got my oxygen, and now I need to draw my hydrogen. And hydrogen, remember, only has 1. So I'm going to draw hydrogen right next to it with its 1, and hydrogen right here with its 1. And then look, oxygen has the 8 electrons it needs to feel complete. Remember this circle right here? It has all 8, so oxygen feels really complete. And then you're thinking, well, what about hydrogen? Well, hydrogen only needs 2 to feel complete because there's just 2 in the first energy level. So hydrogen shares these 2, like this. And then it feels complete. Like you've probably seen water molecules drawn like this before, like Mickey Mouse ears or something like that. That's what this is. Okay, so when you go to this page here, the number of single bonds, it's going to have 1, 2. 2 single bonds. Okay, and the good news is is that almost all of these are single bonds. So the only one that's gonna have a double bond is this one. The rest of these do not have single bonds. Okay, or don't have double bonds. I'm sorry, I said that wrong. The rest of these they all have single bonds except for this one. So I'm gonna cross that off on this one too. Just so it's really clear. There we go. You're not gonna use those lines, okay? So the next one is nitrogen and hydrogen, which together make ammonia. I need to get a clean piece of, well, no, I can use this. Okay, so nitrogen and hydrogen. Okay, well, nitrogen is 7 minus 2, which means it has 5 on the outside. So let's draw nitrogen. 1, 2, 3, 4, 5. And then it likes to bind with 3 hydrogens, and hydrogens have just the 1. So we're gonna draw 1, 2, 3. So this way, nitrogen feels complete with its 8, and the hydrogens feel complete with their 2. And they make a great little bond that forms ammonia. So here on your page, you're gonna write 1 nitrogen, 3 hydrogen. Okay, and it's forming 3 bonds. 1, 2, 3. Okay, the last one, and it is maybe the hardest one, I think. So we'll do this one together, and I think I need another new piece of paper because I'm drawing this too big. Is carbon and oxygen. CO2, very common. It's what we breathe out. It's actually a poison to us, which is why we breathe it out. So carbon here has a 6. 6 minus 2 is 4, so it's gonna have 4. So let me draw that really quickly, C. And then we'll do 1, 2, 3, 4. And then we have oxygen, and oxygen has, we can cheat here and find out that it has 6, but you could do 8 minus 2 is 6. So they're gonna have 6. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Well, this makes it kind of difficult because you're never really going to have the carbon feel all the way complete. So in this scenario, you actually make some double bonds. So what happens here is that carbon actually double binds with the oxygen, and I'm going to start a second video for this.